Okay, my name is Nicholas Bonafiglio. This is the Object Pooler. The Object Pooler was created to solve a unique problem from another game that I'm working on. And the issue is while running hit scan weapons, there are certain upgraded weapon versions that need to fire actors. And basically was running into an issue where uh, spawning a bunch of actors on high fire rate weapons would clearly and predictably cause a large performance impact. So that led to some thought in developing a solution that would uniquely work for a lot of people actually, and how to make it as modular as possible and do as many things as possible while still being very, very simple in code. And so, kind of its initial 1.0 alpha, more beta stage right now is we've got a component and we've got this object pooling component. Um, and so, with the object pooling component, we're able to uh, define a few parameters, and then based off those few parameters, we can call it in C++ or in Blueprint, and then start pooling an actor and then spawning from that pool. Um, and I call it the dynamic object pooler because, well, the size of the pool will adjust dynamically based on the needs once it's running. So essentially, if you have, find, uh, if you have a need and say you do your calculations and you have the fire rate of a weapon and you can calculate based on time and maybe you want to go off of just lifespan or something. Um, you can calculate how many you'll need in your pool. Uh, and maybe your average engagement, the bullet only lives for 2.5 seconds. So you run the math and figure out how many bullets you need for 2.5 seconds of firing. Uh, and you can then initialize your pool, and that's your best guess right there. It's your most accurate guess so far. But if you end up maybe getting some increased fire, say they get a power up, or maybe they get a debuff, or the weapon loses fire rate as durability goes down. Any of those cases, well, you want the pool to adjust. We don't want to just have this giant block of memory that we're reserving when we don't even utilize all of it. So what'll end up happening is the pool, based on when those actors broadcast that they're returning back, um, the pool will realize, well, how many am I utilizing? And if it's never utilizing any of the other ones, it will then um, stop populating and basically closing those ones down. And this is mostly due to right now for a lot of people will end up binding to on destroy, and that's the easiest way for most people to do that. And now I'm going to include another version to where it'll run an internal timer, and that internal timer will allow you to call lifespan within there. So then we're not actually destroying it. We'll just basically handle the return where we hide everything and execute everything else, and we'll still run our broadcast that we're returning, um, but we won't actually destroy it. And so currently that's its initial state, and so there'll be a boolean check here, and then that'll determine if we're going to use actor lifespan to um, call destroy, or if we want to run that timer and then start adjusting things later on. So that'll provide a little bit more flexibility, but right now I'm utilizing lifespan because generally that's how people are handling things, binding to things on destroyed and etc. So this is the most popular way, it is not the most performant method. So that's one caveat to this, is that um, our pool, since it's changing constantly, we're essentially destroying a slot and then repopulating a slot on the back end. Now it's not actually spawning that actor; it's just reserving that memory before it ever gets the chance to be called. So it's ready ahead of time. But that still costs some performance. So there'll be an option to where you'll have an even more performant method. And then throughout here, it has a lot of checks, and I'm working on expanding. If you don't do certain actions, you'll have some error message handling. So it'll guide you through to what you need to do and fill out in Blueprint. Um, so very, very simple. It has a go back, and then we utilize an interface right here, and that is to reset that pooled actor. And that's really it. Then that reset is for any data that you want to reset after it's been returned to the pool. So there's just that option as well. And so I have two examples where we have a static spawner and then just a really simple turret type deal here. And so inside the static turret, the basic timer setup, nothing too fancy there. But on begin play, one thing we have to do is we have to initialize our pool. And that's kind of that best guess, is we're filling out, well, what size do we want our initial pool to be pulling from. And so we can define that through that function. We can also define it here. Async is gone for now. So we can define our pool size. We can determine, do we want it to auto expand and be adaptable, or do we want it to just be fixed and really not dynamic. And then this is that lifespan that we can set. So you can play with this. There'll be another Boolean toggle here, and then this actor lifespan will serve two purposes, and have a tooltip to explain that. And then our pooled object class, we need to set inside of the component, and now we can dynamically end up changing this as well. This actor, the turret, holds a projectile class, and so we can pass that in when we initialize the pool, what our actor class is going to be that we're initializing it to. And then we start a timer, no big deal there. And then every time the turret fires, it's going to spawn a pooled actor, and that's going to work based on that logic that I was showing earlier, where we are working through, we'll end up being able to check that interface to reset the pooled actor, but we're not resetting any data on it currently. And then go through and unhide it in the game, handle collision, handle replication, bind to its onDestroyed, and then iterate through some statistics throughout here that I'm still in the process of kind of fixing up. And so this handles it here. You can provide a transform, and then with that transform determine where you want it to spawn, and then obviously you can get a return out of there. And then if you just need to get one from the current pool, you can call get pooled object, and then you can get a currently hidden object from the pool. If there are none, then it will expand the pool essentially. So how that looks is, if you check on the right, you'll see we have projectile spheres. We start with 10, and since we're bound to the onDestroy, we'll start losing inside of there. So we'll start closing down the amount in the pool that we have, and then from there on out, it's only going to spawn one more slot based on our needs. And so we're down to 5 inside the pool as they destroy, and this will just keep iterating. So not the most performant way, but the previous 4 are loaded and ready to go for when the turret needs them. But we are destroying and creating constantly, so there still is that portion of it. It's just we're a lot more ready, um, and it's not happening every time you pull the trigger, so you won't get that huge lag. And then we have our single sphere here who initialized, and we have a pool of 5 that static spawner can pull from. And so if I go to the turret, actually, and I change it to like 0.35, and you'll see we start out with 10, but we're going to need way more than 10. So it's going to start expanding its pool as it works through that until it gets to a point where it settles and it's like, okay, well, this is all I need. And then it handles it that way. So what that would end up looking like is running the internal timer function to return the object rather than destroying it. Is it would be those same 10 initially expand based on its needs until it gets to where it's happy and can recycle, and then it'll just pull from the returned. So you actually wouldn't see the numbers incrementing because it's just going to be reusing the returned ones. And the important part about that is with our projectile, or whatever we're spawning, if it had any data, I would then need to actually go to our interfaces, and I would need to add, what is it? LMNOP the pooled actor interface. And then with the pooled actor interface, I would then need to go ahead and insert any logic to reset the data with this pooled actor. And that's really important in this functionality. Can't explain how much this will help people in the long run, having the ability to just be able to do things very simple, free, open source. You can modify it as need be, and adapt it to your project. So just something like this will give you a lot of reusability depending on the type of actors that you're spawning. If you're spawning a projectile, not much to really reset in terms of a projectile. So, uh, but more complicated things, if you're spawning AI, then yeah, you may need to reset things related to health and movement speed and current states and stuff like that. So um, basically, you create your little helper function to reset it, and then call your function for reset the actor. So this is an option there. We don't need it currently, uh, but it is available to use. So that just about covers it. Over the next couple weeks, there'll be some big feature updates to really take this thing to the next level before it's ready to go into my game project and be packaged, and then on my GitHub page, I'll be putting my latest packaged release to basically allow me. And I've found a handy tool for packaging plugins. So it'll allow me to basically do multiple engine versions. So I'll be able to manage my engine versions and then have multiple options for releases. Um, so I'm not having to recreate this in all the different engine versions. I'll most likely just keep with the latest two, but I'll make it for 5.1 and 5.2 since I have the ability. Um, that's about it. Thank you for watching.